Hi, my name is Joseph and welcome back to the Shoebox Mysteries. Today we have some very special guests with us, the Potato Heads. So the storyline goes something like this. One day, all of the Avenger Mr. Potato Heads were out saving the galaxy. And for some reason, they were on a very, very popular ship from Star Wars called the Millennium Falcon. And this ship was overtaken by unruly forces, and as a horrible joke of sorts, the Mr. Potato Heads were set floating just outside of their spacecraft. And of course, they have to get back to their spacecraft, but how can they do this? And what do they have to sacrifice in the process? So you remember from my last video that there's this thing called conservation of momentum. And basically what it means is that in order to start moving in one direction, you have to make something else start moving in the other direction. So right now, the Mr. Potato Heads have zero momentum with respect to their starship. But they could get some in that direction as long as they had something they could throw off in the other direction. And fortunately, Mr. Potato Heads have pieces that can come off, so they might just have to sacrifice something. Maybe it's their hair or, something that's not too valuable, so they can get back to their ship. So now that we've figured out how the Mr. Potato Heads might make their way back to the ship, let's make it a little bit more interesting. Let's suppose that the Mr. Potato Heads are drifting away from the ship, all at about 0.1 meters per second. That's about 10 centimeters per second. They're drifting away from the ship. Now, we also have to make a couple of other assumptions. Let's assume that the object that they might throw is going to be about 1 kilogram, and that the rest of their weight with all their other equipment is going to be 9 kilograms. So 10 kilograms in all, but the object they're throwing is one of those kilograms. So how fast are they going to have to throw that object in order to just stop moving away from the ship? And once we figure that out, then we know that if you throw it any faster, you'll make your way back to the ship. So we've got our potato head here, and we have our ship on the left, and our potato head is going to be moving away from the ship at 0.1 meters per second. And she's a total of 10 kilograms, so 10 kilograms times 0.1 meters per second is 1 kilogram times meters per second. So this is our momentum. And the brilliant thing about conservation of momentum is that we can break apart this potato head. She's already moving away like this. Now we can break her apart, and she can throw her hair in this direction, and she'll have whatever speed now, depending upon how fast she threw her hair. And once you add up their momentums, it's always going to be what their original momentum was. So this is really useful and will help us write an equation here. So this is the part of the equation with her hair. This will be the momentum of her hair. This will be the momentum of the rest of her. And this is what these two terms combined will always equal. They'll always be 1 kilogram times meters per second. So if we're asking the question, how fast does she need to throw her hair just to stop moving? Well, if she's going to stop moving, that means that her velocity is going to be 0 meters per second. So this whole term just goes away. And we're left with just one term on this side and one on this side. This is 1 over here. So this term has got to equal 1. And by observation, we know that she has to throw her hair at 1 meters per second. And that's how fast it'll be moving relative to the ship. So this is the answer right here. And as a bonus question, how fast should she throw her hair to return at the same speed that she left the ship? So she left the ship at 0.1 meters per second. She wants to return to the ship at the same speed. Since she's heading towards the ship now, her velocity is going to be negative. So negative 0.1, and that's meters per second. And I'm not going to solve this for you, but if you solve for this term right here, you're going to end up with 1.9 meters per second that she has to throw her hair in order to return to the ship at the same speed that she left the ship. Now there is a question about Thor. I mean, when he throws his hammer. Anyway, I'm going to let you guys sort that one out. Thank you guys so much for watching. If you enjoyed this, then please subscribe, and I look forward to seeing you all next time.